Hi everyone, welcome to part 3 of project 2, which is on multiple linear regression. So we have completed the visual inspection of the feature and we have seen that the salary is the most influenced feature. Now it's time to extract the features and to extract the labels from this new data frame. So let's extract the features. So these are our features: salaries, research and infrastructure. And now these features are in the form of data frames. We want to transform them into the NumPy array. So we have to write x dot values. So we need the values of the feature. Now we can see that this is now in the form of NumPy array. Similarly, we can extract the target value. The target value is present at the last column. And the last column will be represented by -1 in the data frames. So let's run this cell. So we have extracted y in the form of values, that is in NumPy array. We have extracted x in the form of NumPy array. Now it's time to perform train test split. So in a function train test split, we have to pass our features, we have to pass our target values, then we have to set the test size. So the test size is 0.2. 0.2 here means 20%. So basically we are splitting our total data into test and train, where the testing data will be at 20% and the training data will be 80%. So here I am passing random state is equals to 42, and this is again to ensure that every time we will get the same data samples in the training and testing split. So here we want to check the shape of x test.shape. So we are getting error. So we need to run this cell first. And here we are getting x test. So basically the train test split function will return 4 values. That is a training part of the data set, the test part of the data set, the training labels, and the testing labels. Now, if you want to see the shape of a x test, the shape is 200 because the test size is 20%. Therefore, the 20% of 1000 is 200. So if you remember in the part 1 of this project, the number of samples in our data sets are 1000. Now the data has been split. Now it's time to standardize the data. So in order to standardize the data, we have to import standard scalar from scikit-learn.preprocessing. Since standardization is the pre-processing step, therefore it is present in scikit-learn.preprocessing. Here we are instantiating the standard scalar and the variable is called sc. Here we are fitting and transform our standard scalar to the training data. And here we are transforming our x data to a standard scalar. Now here we have to remember few very important things. First of all, first we have to split the data and then to standardize the data. It is very unethical to standardize the data first and then do the splitting. In that case, when we train our model will be able to see some part of the testing data. In that case, there will be a term known as data leakage, and that data leakage will be happening and the performance of our model might be increased, but it is not a practical one. So the first step always is to split the data. Always split the data first and then do the standardization. Now, another important step in standardization is that when you have to standardize the training part, you have to use fit transform. The fit value is used on a training part only. So here we are fitting means we are using a training part and we are use a transform here in order to transform the training part into the standardized form. But for X test, we will not do any sort of training. Therefore, there will not be a fit function here. So we will only use a transform here. If you use fit underscore transform here, again, there will be a data leakage. Data leakage means that our model will see the testing data. So this should not happen. The testing data should be the unknown data for our model, and our model should not see any part of a test data during a training. So if we write fit transform here, the data leakage will happen. So if I run this cell, I have successfully standardized my data. Here I can see the standardized form of our data. So all the values of features are within the range. Previously, the features are of different range. So what will happen in that case? In that case, it will happen that the features with the large values may influence more on the output value. So in order to make the analysis fair, we need to standardize the data. Now it's time to apply linear regression. So here I am instantiating my linear regression. Here I am fitting my linear regression on my training part of the data. So you can see that this is X train and Y train. This is a training part. So here I am instantiating. Here I am training. Now I am getting my intercept. Now you can see that I have three features. The value of first feature is 409. The value of second feature is 1557 and the value of third feature is 1229. So the value of second feature is large. So which one is the second feature? So if we go back, we can see that the second feature is salary. And if I go back and we see in our inspection, we predicted that salary is the most important feature. And when we will calculate the weight of all these features, we will get the highest value of the weight of a salary because it is most linearly established with the expenditure. It is highly correlated with the expenditure. So it will have more influence on the expenditure, which is our output value. Now with the value of weights, it is confirmed that salary is the most important feature. Also, this feature is also important. The third feature, which is infrastructure, and this feature has also some value, which is 409. So we have confirmed with the calculation of the weights that the most important feature is the salary feature. So this is the advantage of visual inspection. In visual inspection, we see the effect of the features on the target values, and then we will confirm this by calculating the weights. So here I am using lr.intercept.round2. So I want the values of a weight or a bias. So this is my intercept or a bias to 2 places of decimal. Now it's time to testing and evaluate the model. So this is the training part. We have used the training data in order to calculate the intercept, which is the bias value, and the coefficients, which are the weight of the model. Now we have a testing data as well because we have split the data. So the command is lr.predict to get the predicted labels. So we have getting the predicted labels here. Now it's time to evaluate the performance. So we have trained the model, we have tested the model. Here we have testing our model. Now it's time to evaluate the performance of a model. For evaluation, we will use RMSE value, MAE value, and R square value. So we have imported these metrics from scikit-learn. So for RMSE, we are using np.square root metrics.mean square error, and we are giving two inputs, y-test and y-predict. So y-test are the target values for the test part of the data, and y-predict are the predicted value which are given by the model. So let's run this cell. So we can see that the name test label is not defined. So basically we have used a test label here. So the original variable is y-test. So we have to remove or replace it by a y-test basically. So this is a typo. So y-test. So if I run this cell now the y-predict.test is not y-predict_test. So this is only a y-pred. So there is again a typo here. So I need to confirm y-test, y-pred, y-test, y-pred. Now it should be okay. Now we can see that we have root mean square value, which is approximately equals to 0. You can see exponent raised to -12. So this is a so small value that we can call it a 0. The computer is not giving, or a Python is not giving exactly 0. So this is a computer rounding error. And we can see that R square or R2 value, this is equals to 1, which is the maximum possible value. So we can see that the root mean square value is 0, the mean absolute error is 0, and R2 is 1. All these values are ideal values. So we obtain this value because we have created our own data set. The purpose of creating this own data set is that I want to show you the ideal value. That is the values which should be ideal for root mean square error and for mean absolute error. So the ideal values are 0. So if you use any of the real data set, if you download a real data set from anywhere, or if you use any real data set, you will never get RMSE or mean absolute error equals to 0, and you will never get R square value equals to 1. So therefore, the purpose of generating our own data set first with the help of a function make regression and then transform this data into a real data of a company is to show you how you can achieve the best possible model using a multiple linear regression. Now let's interpret the coefficients. It's time to interpret the coefficients or interpret the weight. So we have the weight value of 409.54. It means this is the weight associated with the research. It means if I add $1 in a research, my expenditure will be increased by $409. Similarly, if I add $1 in my salaries, my expenditure will be increased by 1,557. And similarly, if I increase $1 in my infrastructure, my expenditure cost will increase by. So the salary has most effect on expenditure. If I increase $1 in the salary, my expenditure will be increased by 15557.34. So this is the interpretation of the weights, that how weights are affecting and how features are affecting the target variables. Now let's further evaluate our model. So this time what I am doing, I am getting only one data sample. So I have a test data and the shape of the test data you can see is 200. So rather than passing 200 samples directly, I am using any of the sample, and here I am extracting the 113 samples. So out of 200 sample, I am extracting the 113 sample and I am reshaping it to the form of the features. That is, we have 3 features. So let's run this cell and we can see that we have one sample and 3 features. Similarly, I am extracting a test label for this sample. So this is my test label, and now I am getting prediction from my model for this sample. So this is the predicted value. So what I am going to do, I am going to evaluate my model further. Here I have evaluated my model on 200 sample. Here I am taking only one sample. So in this lecture, you are also learning that rather than passing 200 or 300 samples directly to the model, how to pass a simple sample or single sample. So this is the sample and this is the label associated with the sample. Here we are getting the predictions from the model about this sample, and here we are calculating our values. Now you can see that again, our model is so good that root mean square and mean absolute error are 0. We can confirm from here that the values are 0. Now here is another very, very important thing. You can see that R square or R2 value is not a number. What is the reason? The R square score is not well defined with less than 2 samples. So this is another very important learning. If you want to calculate R square, you need to pass more than one sample. So you see, there are a lot of learning in this project 2 on regression, which is a multiple linear regression. So if I want to summarize this, that what you have learned in this project, so basically first you learn how to create your own data set using a function make_regression. Then you learn how to transform the random data into a data set of a company. So for this, you use the features research, salary, and infrastructure, and you transform your target values into the expenditures. Then you visually inspect your features and you see the salary is the feature which is highly correlated with the expenditure and it has more influence on the expenditure. Then we split the data into test and train. So the most important thing to remember is that we have to split the data first and then we have to do standardization. After standardization, we apply linear regression, we calculate the bias and the weights, and we confirm that salary is the most important feature. Then we evaluate our model and we can see that all these values are ideal. So these values are only possible if you create your own data set and if you set up a thing in such a way that you can get this ideal value. When we apply a multiple linear regression in project 3, in next project, we will see that we will use a real data set, and in a real data set, it is not possible to reach r square is equals to 1 or to get the root mean square value or mean absolute value equals to 0. Here we interpreted the coefficient. We further evaluate our model since we are getting a very good result. So we also wanted to evaluate our model further. So we also learn how to pass a single sample to our model. So we select a sample which was 113 sample. We find the test label or label for that sample. We get the prediction from our model for that sample. We calculate the root mean square, mean absolute error, and the R2 value. So we see that we were unable to find the R2 value, and the reason is for calculating the R2 value, we need at least 2 samples. So I hope you understood this project too. Thanks for listening, and I will see you in the next lecture.